welcome him.
Perfect, thanks. Fantastic. Good. So, hello everyone, and I'm super excited to be here talking to you about a topic that I really deeply care about. My first touch point with Web3, more specifically with Bitcoin, was somewhere in 2015, where I got approached to work on a project that was basically allowing to pay for a coffee with Bitcoin before your coffee would get cold. Now, it's a very simple use case, but remember back then, most people were still running around with laptops as their wallet, so that needed to change. And also you had this issue of Bitcoin blocks coming out only every 10 minutes, and people telling you you have to wait for 6 confirmations. So after 10 minutes, your coffee is cold, and after 1 hour, for sure, it's entirely ice cold. Now, out of that specific project, 2 things happened. On one hand, I moved on because my background was in mobile security, working with Credit Suisse in the mobile banking apps. And I said, okay, let's apply the knowledge, move it to a mobile device. And we were working together with Christian Decker on state channels, which later on then got rebranded as the Lightning Network. And the reason why I'm bringing this all up today and why this is relevant for universal interoperability, because I believe that we are at a very similar stage, right? So already back then, the reason why we would try to solve this issue was because of having an easier, so lowering the entry barrier for users, making the technology more accessible. And the same thing is actually happening now with this concept of universal interoperability, where we say, okay, interoperability is a very interesting concept if you talk chain to chain, but why not extend this concept and also include things like Web2 technologies, or also then start thinking more holistically, more universal, even including then things like AI models. So how can those start interacting with all of these other components? Because you see today you have many ecosystems that are struggling to find adoption and are also very isolated in themselves. And this creates, of course, a huge opportunity, because if you're able to start allowing users to choose whichever tech stack that they want and they feel comfortable with, and then allow developers to choose whichever stack they want to use for their applications, well, then you basically unleash the whole promise of Web3 and ultimately also drive the adoption there. And this is exactly what we're basically doing with Acurast. Acurast is a abstraction layer that we're offering to developers to interact in a seamless way with all of these components, modules that are in there. These components can be different layer ones like Bitcoin, Ethereum, the Polkadot network, but then also technologies like AI models, Web2, and so on and so forth. Now you may wonder, okay, this sounds very nice vision, super exciting, but talk is cheap, show me the code, right? How this is actually made possible is, fantastic, is through a new architecture that separates the consensus layer from the execution and settlement layer. And what this ends up giving us is a way to have modules that come with different properties for the different execution environments. This means that you can have an execution environment which is run by trusted hardware. You can have an execution environment that is run by zero-knowledge proofs. Like, you decide which properties are really important for your tasks and jobs, for this universal interoperability tasks and jobs, and then where ultimately you want to settle. This means that in the end, you can build your full stack as a parachain, yet still allow people to come in from Ethereum or from native Bitcoin. And that's what we, in the end, call the universal interoperability layer. This is already available today. Like, people can already create this. People are already creating such jobs. And the environment that we have today is using, again, because that's my background, mobile devices as the hardware running this. Now, you may wonder, okay, mobile devices, why? Mobile devices turn out to be the most powerful hardware security modules out there. And if you think about it, it is also quite intuitive, because a server has the privilege to be in a physically secure location, while a mobile device, actually, you can, it's mobile, so you can forget it somewhere, or someone can steal it from you. Yet we want to use the mobile device for very financial transactions that are super important to us, or manage our identity, and so on and so forth. This means the engineers at Apple and Google had to come up with hardware that would enable this vision. And this is also where we're taking that as an advantage and build the entire stack on top of this hardware. So basically, the execution layer runs on what we call a processor, and a processor is basically a device. Here we can show you how the onboarding works. This is the other very good advantage that we have from using mobile devices over servers. A user purchases a device, scans a QR code, which is linked to their crypto account. In this case, it's a Polkadot JS account. And then this device is being 100% dedicated to the Acurast network, is a processor, and is starting to work only for that network. What is also happening is that the device will no longer be usable for anything else. So it's really just locked down and dedicated, and yeah, me as an operator of this device will not be able to see what kind of jobs are actually being executed, or the data that the jobs are handling. Now you see it's locked down and dedicated to just the Acurast network. Why would someone do that? Well, of course, the reason most of the time is money. And the reason in this case is that you end up having a device that earns rewards for you. So you dedicate the device, and you first invest in this hardware, and then you dedicate the device to the network, and hopefully you're able to get a positive ROI. Mobile devices are amazing for that, because they have a very low energy consumption and actually pack quite a punch of hardware, computational resources. People are now already doing these kind of farms of devices where they're just purchasing phones that have cracked screens, because you don't actually care about the screen, and then dedicate them all to the network. Well, this was now the part of the processor. Let's quickly touch a little bit more on the part of who is actually using this, the developer. The developer has an abstraction, which was this Acurast universe I showed earlier. And by only interacting with this abstraction, they can then start settling on native Bitcoin, on native Ethereum. They can also have, when we're thinking about abstract accounts, a trigger that comes from the Web 2, like a FIDO, session or an OAuth session and control their account directly with that. All within this execution environment that we provide, and they don't need to get involved, purchase some tokens for a different chain to be able to settle on that chain. We currently have already a couple of integration for a couple of chains and a couple of stacks. I mean, native EVM, WASM with Astar, we did that integration, and then also other layer ones. There is a substrate palette. The idea here, however, is that, of course, the community starts also building their own modules, their own settlement modules that they can then use. Now, let's make it even a little bit more concrete. The place where the processor meets the developer is in the Acurast marketplace. This is where a processor can say, okay, I value my resources at this price, and then a developer can say, okay, I want to have this job executed, I'm willing to pay this price, and if they match, then of course the job will be done. If they don't match, then at some point there is a market mechanic where someone either needs to come down with the price or go up with the fee that they're willing to pay. The use case we have now already running in production is a DeFi platform called Youths. Youths is a platform that holds more than 50 million worth of digital assets in their smart contracts. And the example why I'm bringing this up here is to show you how flexible the whole thing actually is, because they started with a custom script, a custom job to observe prices outside of the Web3 world and then bring them onto the Web2 world, the classical Oracle use case, then moved more into a common good price feed model where they said, okay, it's not only for us, we are now observing also other assets for other projects so that everyone can use them. And now they're moving to the last evolution of this, which is the on-demand setup. And in the on-demand setup is where the user actually talks directly to the processor, so directly to the execution layer, and does not need to go through the hassle of going through the consensus layer and having block times limiting the user interaction. Other use cases we're currently working on, of course, the ability to have this seamless cross-chain communication where you have one ecosystem that is trying to open themselves up to another ecosystem, like I am a Polkadot parachain developer and I want to access the audience of Ethereum users without having them to switch the tech stack, without having them to purchase some native tokens off my chain and so on and so forth. Like everything is completely abstracted away and people can then just seamlessly interact with your application regardless of the tech stack that you've chosen. Other use cases are like multiplayer games because, I mean, this is kind of more a pet project, but you can apply it to other things as well. Think about a poker game. Nowadays, you cannot make it fully decentralized on-chain because the minute the randomness gets revealed, everyone knows the cards of everyone else. Because of the confidential computing properties, now you are able to actually have a provably fair environment where only the environment knows all the cards and people can then start interacting with each other. And last but not least, goes in a similar direction, is the ability to train and use AI models in a confidential computing way. This means that instead of just handing out all of your data to centralized parties like Amazon, Google, and Microsoft, now you can say, okay, I'm going to just spread this on this network of confidential computing processors that then bring back the actual result. Perfect. My last slide here. If you're excited the way I am about this topic, you very happy to reach out to us. Yeah, there's a couple of ways to get involved already today. On one hand, if you're a processor or a developer, head over to console.acurast.com. If you are a developer and don't trust what I just said, want to read more about it, you can go to the docs. You can also reach out to us. We have Christian with us today, our head of research in the audience. I'm here as well. And of course, if you want to see the latest development, you can head over to the Twitter account of Acurast. Thank you very much, and yeah, have a wonderful week here in Paris.